I'm live. If you're here, write something down on the bottom. Let me see. Right now I'm wondering if the screen actually flips over like it needs to so that this reads correctly. I need some help. All right, so this actually reads like it should, Phoebe. It says, hi, everyone, and you can read it correctly? Excellent. All right, well, you're the only one in the room, so if you've got questions, go ahead and ask away. I'll do the best I can here. Just tell me what number. I've got it all here as well, so. All right, 61. All right, bear with me here. All right, problem 61. We've got cosine x plus y, cosine x minus y, verifying the cosine squared of x minus sine squared of y. Okay, everything shows there fairly well. I know we're going to have some issues with focus, but we'll do the best we can. So that looks correct as you see it. All right, I'm assuming everything looks fine. All right, so in this particular case, I think it's going to be easiest to tell. We're not going to try to verify to go to the cosine squared minus sine squared and bring it back to this side. We're going to use the sum and difference formulas here to expand both of these. Now, that is a multiplication that's going on in between here. So when I do this, I've got to be careful on how I write. Now, let me know if the red pen, I'm going to just stick with the black pen here. I think it's got the best contrast. All right, so expanding cosine of x plus y, I'd have cosine of x, cosine of y minus sine of x, sine of y. I'm going to want that in parentheses here because I'm multiplying it with the expansion of the other one. Cosine of x, cosine of y, plus sine of x, sine of y. All right. So what we need to recognize here, that in the first parts, which I'm guessing you're probably okay with, is that we have essentially the difference of squares, a minus b times a plus b, where here's the a, here's the b, here's the a, here's the b. So when they multiply, we're going to get a squared minus b squared. Okay, so the same thing's going to happen here, is that I'm going to have, in this particular case then, I would have cosine squared of x, cosine squared of y, because I'm squaring this whole thing, cosine of x, cosine of y times cosine of x, cosine of y. Middles drop out, leaving us a minus of sine squared x, sine squared of y. Then from here, since we're looking to get to cosine squared of x on its individual and sine squared of y on its individual, what we're going to need to do, we've already got the cosine squared of x here, so we're good with that, which means we have to manipulate cosine squared of y. Pythagorean identity would allow me to say 1 minus sine squared of y. And notice what this will do is now I can distribute the cosine squared of x here, and that isolates cosine squared of x. Now, I'm going to do the same thing on the other side. I'm going to do it over here, but keep in mind I already have the sine squared y here. So what I need to do is manipulate the sine squared of x. So in that case, I'm going to use 1 minus cosine squared of x times that sine squared of y. Now in doing that, the same distribution, I'm going to get the following. I'm going to distribute the negative and the sine squared of y at the same time. Okay, so notice that when I do that, I'm going to be subtracting sine squared of y, but then I would be adding cosine squared of x sine squared of y. What will happen then is if you take a look at this term here and this term here, they go away. So we get the cosine squared of x minus the sine squared of y. How's that? Okay, I'm going to assume that things are good. So I'm going to move on to problem number 71. All right, problem 71. Here we've got the cosine x plus pi over 4 minus the cosine x minus pi over 4 equal to 1. Okay. All right, same kind of thing. We're going to expand on both of these, and chances are, even though it's going to get big to begin with, it's going to fall apart pretty quick. So here we go. All right, so cosine of x, cosine of pi over 4, minus sine of x, sine of pi over 4. I'm going to keep that all in parentheses here because I have to subtract it with another one, so I've got to be very, very careful of this negative. The most common mistakes that people will make is they forget to distribute the negative into that entire group here. Cosine of x, cosine of pi over 4, plus sine of x, sine of pi over 4. Now, this is all equal to 1. I'm hoping, can we see the 1 out there? Good. Now, I'm not going to substitute anything in yet. I could for the sine of pi over 4 and the cosine of pi over 4, but I think I'm going to wait because as soon as I do the distribution here of this negative, okay, what's going to happen is that this is going to become negative and this is going to become negative. Now, to save a little time for me in writing, consider that distribution is taking place. Okay, so I'm distributing here. That's now going to be a negative. Distributing here, this will now be a negative. Okay. Then I can remove the parentheses from here. And now take a look. We now have a cosine of x cosine of pi over 4 minus another cosine of x cosine pi over 4. So those are essentially going to eliminate themselves, and now we have 2 of these. So we can say negative 2 sine of x sine of pi over 4 is equal to 1. Now we get to make that even a little bit better since we know the sine of pi over 4, sine of pi over 4 being radical 2 over 2. Now that even works out well because now what's going to happen here, because I can think of this 2 out front as a 2 over 1, I can now reduce it with the denominator there. Now, this is not normally where we would write this. I'm going to bring this out front, and I can write it as the negative of radical 2 times the sine of x is equal to 1. Now we'll go ahead and move the negative radical 2, so we get the sine of x is equal to negative 1 over radical 2. We will need to rationalize that. So the sine of x is equal to negative radical 2 over 2. Now, in this case, we are looking at doing this on an interval from 0 to 2 pi. So all I need to do now is take a look at where that's going to happen on our unit circle. Since the sign has to be negative, quadrant 3, quadrant 4, we're looking down here and down here. So x would be the 5 pi over 4.
Mr. Courtney,
and the
please
7
report
pi
to
over
the
4.
main entrance, first floor. Mr. Courtney.
Okay, would be the 5 pi over 4.
Mr. Courtney,
and the
please
7
report
pi
to
over
the
4.
main entrance, first floor. Mr. Courtney,
Okay.
please report to the main entrance, first floor lobby.
As you can see, we still have our announcements that go on here. Okay, so that gets 60. That gets those 2 problems. I see we've got a couple of other people that have joined us. What else? First of all, is this good? Let me know if you got it, if it makes sense. I'm assuming there must be a little bit of delay in writing. Either that or post an emoji, something that lets me know we're good to go, and then I'll move on to whoever's got another problem. All right, so there are those 2 problems. All right. 72, absolutely, Michelle. Here we go. All right. So in 72, we have the tangent of x plus pi plus 2 times the sine of x plus pi equals 0. All right, so in this one, let's go ahead and expand it. So here we will have the tangent of x plus the tangent of pi over 1 minus the tangent of x, tangent of pi. Okay, so we'll maybe want to calculate this before we go a little further because I have a feeling some things are going to happen there. So again, I want to keep that in a group to begin with on my expansion. Then on the second one, what I have to keep in mind is that 2, I'm not doing anything with this 2 yet, but I will expand the sine of x plus pi. So the sine of x, sine of pi, or excuse me, cosine of pi, I'm sorry, plus cosine of x, sine of pi, and then that is all equal to 0. Now, keep in mind, you can do the substitutions of these values at any point in time that you want. In this particular case, I'm going to probably do a little bit just because it might help clean some things up. Now, let's take a look at that idea of tangent of pi for a second. Okay, so tangent of pi is going to be equal to the sine of pi over the cosine of pi. Well, the sine at pi is 0. Cosine of pi would be -1. So overall, that's 0. So what's going to happen in this first piece altogether is that essentially the tangent of pi is 0. So I'm going to get a 0 here as well. Now, because this is a multiplication by 0, I essentially am getting everything over 1. I'm essentially losing the denominator completely here. So what that leaves us with, all because of that 0, 0 here, 0 here as a multiplication, 1 minus 0 is 0, denominator eliminates. I'm left on this one with just tangent of x. On the other one, I can argue that the cosine of pi, that's going to be a -1. The sine of pi is 0, so I'm going to lose, if sine of pi is 0, this all becomes 0. That completely goes away. The cosine of pi is equal to -1. So what happens is that this becomes a -1. So by the time it's done, I'm taking and having, I've got 2 times the sine, or excuse me, not a positive, but a -2 sine of x. Okay, so let me check with you, Michelle. Were you able to get to this point? Excellent. Okay. So then from here, because we've got tangent and sine, I'm probably going to have to look at this from a perspective of looking at some sort of an identity here. So I think because I'm a mixture of tangents and sines, what I'm going to try, now this is not a guarantee. Again, I got to try things. I'm going to switch the tangent to sine of x over cosine of x. All right. Now, because of the fact that I've generated a denominator here, this is also going to give us a restriction we have to consider, is that cosine of x cannot be equal to 0. So again, that's going to eliminate some values. If we consider where that's happening, that's going to happen at pi over 2 and 3 pi over 2. So x will not be able to equal pi over 2 or 3 pi over 2. Now, with that happening, I can now essentially clear fractions here. I'm going to multiply every term by cosine of x. Now, it's kind of nice because when I multiply by cosine of x on this side over here, this is just going to drop away and still be 0. And in my first term, I will end up getting a reduction here, leaving us then with sine of x. Multiply this as 2 sine of x cosine of x equal to 0. And now what we have is the ability to then factor a sine of x. Now I know I'm getting a little bit low on the board here. So, and I'm hoping that maybe at this point in time, you'll know where to take it from here. So I can take, after I factor a sine of x, that's going to give me 1 minus 2 cosine of x. Now I can separate sine of x is equal to 0, 1 minus 2 cosine of x is equal to 0, and I can solve. Okay, so then from here, now it's just a matter finishing them off as we normally would. Would I be correct in my assumption that the issue was maybe the transition from tangent of x minus 2 sine of x to where to go? I do realize there's a little delay here in terms of responding. That's okay. So we'll work with what we can. All right. So Michelle, you're good to go? All right. Excellent. Okay. Let's keep going. I see we've got quite a few people in the room. We've got 7 that are here. Thank you for coming. It's very, very quiet in here, and there's a big echo. All right, so let's keep going. Do we have any other questions we want to take a look at? And no, I'm not playing any music because I'm taking off a shirt. Okay, if we've got other questions, let's go ahead and write it down on the bottom. I see 7 of you in the room. I don't know who you are, except for Phoebe and Michelle. So things are looking good there. If there are others that have questions, let's go ahead and put them up. Don't feel like you can't ask if nobody's putting anything up. I'll hit the ones that people would like. Okay, no questions have come up yet. See, we have somebody new who joined the room. Welcome aboard. Okay, I'm going to give it another minute here, so if there aren't any other questions that come up within that minute, right now I've got 9:38. If there are no other questions, I'm going to give it a minute, and then we'll call it good for here, and hopefully that helps. Please keep in mind that I'm going to let you go ahead and redo the 5.4 quiz now that you've had a chance to ask a couple of questions. You can redo the 5.4 quiz. You can resubmit it. Please make sure that you're doing at least a little bit of explanation with it as to how you're getting through your problems, okay? Yeah, it kind of is. Jolie's not here. Well, if anything, though, the good part of it is that if people are understanding what they're doing, we should be good to go, okay, which is always a good thing. Right now, since we're still kind of waiting on some things, no other questions have come up, I have uploaded the video for the first part of section 5.5. That video, though, is going to take a while to upload in Google, because Google needs to optimize it, so you can expect that that'll be sometime this evening. You'll know when it's ready, because when you go in there, you'll see it. It'll look like an actual movie thing that you can click, but it will be ready to go. The PDF document is in Schoology. The PDF document is just our PowerPoint without the writing on it. But at least download that, bring that into Schoology, or into Notability, and then you'll be ready to go, where you can just take the notes as you go. Hopefully things on the board that I did this morning with it will come out. I know there's a little bit of a focus issue that takes place, but I'm hoping that that works out pretty well. Please let me know some feedback on how that works once that's in. We'll just do that in the first update there. At this point in time, are there any other questions at all? Last call. Okay, so give me a thumbs up if you're good to go. Just do an emoji thumbs up if they've got it. Something that lets me know you're good to go. Okay, Haley, you said nope. Do you have something? Okay, there's the thumbs up. All right, everybody. If you do have a question on something, please don't hesitate to try and post it as in the updates. Leave a comment there. Whatever is good. But I'm hoping that this worked well. I will be back online doing this same thing at 9 a.m. tomorrow morning. Chances are I'm not going to be here at school, because the way they're making things sound is that we are closed down completely here. We're not even going to be allowed in the building. So tomorrow, be expecting that I'm going to be doing something at home, maybe a little less echo. And from there, everybody, have a great night. We'll see you tomorrow.